information. Okay, when it comes to the integration of exponential function, just like how we understand the differentiation itself, when we differentiate our exponential function, we know that it remains the same. So if I were to integrate, let's say ex, okay, naturally it will be ex plus c, it remains the same as well. Okay. Then if we were to integrate ax plus b, okay, it will be equals to 1 over a e to the power of ax plus b, and then followed by plus c. So we keep the function, and then we make sure we divide by the coefficient, okay, of x itself. Right? So that is for integration of exponential. Then when it comes to integration, sorry, that's a differentiation, I meant integration. Okay, so when it comes to integration of reciprocal function, okay, under what circumstances do we actually arrive at this? It is when we differentiate logarithms. Okay, we can differentiate logarithms and we arrive here because we know that, let's say, if I want to differentiate ln 3x plus 7, for example, okay, we have learned that it will give us 1 over 3x plus 7. So integration is the reverse. That means that when I integrate a function like that, I am supposed to get back logarithm itself. Okay? And this kind of function, notice that it is the same as 3x plus 7 to the power of negative 1. So whenever it is the power of negative 1, okay, we cannot actually consider the usual, okay, power rule of integration where I add 1 to the power and then divide and so on. Okay, so when we see that it is power of negative 1, we need to realize that it draws back to our logarithms. Okay, so therefore, integrating functions like 1 over x, it will bring us back to our logarithm, our natural log ln x plus c, or when I integrate 1 over ax plus b, it will give me ln ax plus b dividing by a, okay, and not forgetting plus c. Right? So these were the things that were covered, okay, in the SLS lesson, knowing this skill itself. Let's do some example, because I could see from the quiz that you're still not that familiar, okay, for the most of you. So looking at try 12, if we integrate e to the power of 3x plus 1, okay, by applying what we know over here, that will mean that we keep the function, okay, e to the power of 3x plus 1, followed by dividing by 3, the coefficient, okay, and not forgetting plus c. Perfectly fine if you want to express it in this manner as well. Either way is right. Over 2e to the power 1 minus x. Okay, well yes, it does look something similar to a reciprocal function. I want us to observe that the denominator, okay, is exponential. It is not satisfying either one of these conditions, whereby it is either an x or linear function. Okay, so in this particular case, you could rethink about it by seeing it as though it is half, okay, of the integral e to the power 1 minus x dx, where I take the half out, okay, and then e to the power 1 minus x, or rather 1 over e to the power 1 minus x, is the same as taking it as e to the power negative 1 minus x as the power, which simplifies half, okay, e to the power of x minus 1 dx. Okay, so we see that we're trying to integrate an exponential function. Okay, the power is a linear function in the ax plus b form. So we follow this rule and we get the half stays outside. E to the power x minus 1. Okay, we will divide by 1, alright, because the coefficient of x is 1. Okay, so maybe I'll just be a bit more intentional. Alright, but we know that, okay, dividing by 1 keeps it the same. And not forgetting to plus c. So you can see our answer as this. Okay. Questions? Right on. Okay. Maybe let's try 13 a skip first, since we're talking about covering these skills. Looking at try 14. Okay, if I want to integrate 2x minus 3 over x dx, again there is no quotient rule. Okay, so we got to actually simplify this fraction over here first before we can do anything. So what we will do is to recognize that it is the same as 2x over x minus 3 over x dx. This thing can simplify, cancel away the x, we will get 2 minus 3 over x. Okay, 3 over x is the same as 3x to the power negative 1, or rather you can see as 3 times 1 over x, which fulfills this part here. So maybe intentionally write this. Okay, so that you can see that we're going to integrate part by part. So integrate 2, okay, will give us 2x. Right? This is just a constant number, so I'll just keep it there first. Integrating 1 over x will give me ln x. And then I'll follow with a plus c. Okay. For part B, integrating 1 over 1 minus x is slightly more straightforward. Okay, so let me just get someone tell me what would this integration be. Cheyenne, what do you think? In this case? Sorry? Ln 1 minus x. Anything else? Over negative 1. Anything else? Plus c. Great. Okay, not forgetting the minus 1 because the coefficient of x in this case is a negative 1. Okay, so that tends to be forgotten as a negative 1 here. Okay, so that means that we have negative ln 1 minus x plus c. Okay, this is good enough as answer already. Okay, don't need to go and apply any log rules and make your life difficult. And then, if I want to integrate 1 over 3x minus 2, okay, what will our answer be? Xue Jian, what do you think? Ln 3x minus 2? Out of 3 plus c, great. Okay, so can leave our answer like that already. Okay, or if you don't like it, to look like this form. Alternatively, it is this. Okay, or if you are interested to apply your logarithm rules, okay, it is the same as bringing the 1/3 up into the power. write it like that. Although I don't find it necessary now. Okay? Just trying to get us to practice our logarithm rules. Remember, if there's a constant number in front, we can bring it up to become the power. Okay? But really not necessary to leave it as this answer. Okay? Right? So that covers, okay, the basic skills when it comes to integration of your exponential and your reciprocal functions. I want us to go back to the quiz question, okay, because I have not yet covered question 1E as well as 1G. Okay, so for 1E, we're looking at integrating exponential function. I have e to the power of x over 2 minus 1. Right, so we want to be very careful about what exactly is the coefficient of x in this case. The coefficient of x is actually half. So eventually we will be dividing by half. Okay, and that was some of the mistake, okay, that was being made. So integrating our exponential in this case, we do get back e to the power x over 2 minus 1. And then what we're dividing by is divide by half. Okay, so just by doing this part first, dividing by half is the same as multiplying by 2. So our answer should be 2e to the power x over 2 minus 1. Okay, then to follow with the plus 2x, that will be plus 2x squared over 2. Okay, and then with the plus c. So these 2's cancel out, so you get plus x squared plus c. Okay, just want to emphasize that this 2 over here is a result of the power, okay, not because of this number here. Right? And then also looking at question 1G. Intentionally, choose such a question just to confuse you a little bit, okay, and see how much of the concept that you remember. Okay, so we're going to integrate this in parts. Okay, so 1 over x, when we integrate, okay, we will be looking at ln, because this is what is shown here. So for the first integral, we're getting ln x. Okay. Now for the second integral, okay, for those that are certain that you can see that this integrates to ln, it makes you think that this is going to give you ln as well. But this doesn't give us ln because the power, okay, is square. And in order for us to get ln, okay, the denominator is always a power of 1. Alright? So this actually is your x to the power of negative 2. Okay, and we're supposed to integrate using our power rule, right, which is actually minus x power negative 2 plus 1, that gives us negative 1 over negative 1. Okay? And then for the third part, we have 1 over 3x minus 1. This satisfies your logarithm again. So we are looking at plus ln 3x minus 1 divided by 3 and wrapping up with a plus c. Then we simplify to get ln x plus this x can bring down, plus because minus and minus, followed by plus 1/3 ln 3x minus 1 plus c. Okay? There were some of you who tried, okay, and it was almost correct just because you forgot this set of brackets over here. These brackets are necessary because the 3x minus 1 is with the ln. If you don't have the brackets, then your minus 1 is outside of the ln already. So do be careful about how you place your brackets or how you not place your brackets. Okay? some application questions. So looking at try 13. Already when we were looking at 16.1. Okay, so we are given that the derivative is 1 plus e to the power negative x. Some information about this curve is that y equals to 4 when x equals to 0. We want to find the precise equation of the curve. So in order to do that, we need y equals to something, and that is done so by integrating your dy over dx. Okay. Integrating 1 will give us x. Integrating e to the power negative x will give us the same thing back, but not forgetting to divide by negative 1, which is the coefficient of x, and followed by a plus c. Okay, we want the precise equation. This is part of the equation only. Okay, to find the precise one, we need to make use of this information where x is 0 when y equals to 4, or the other way around, when x equals to 0, y equals to 4. Okay, so your y is equals to 4, x is 0. Okay, typically, okay, some people like to do mental calculation. And then they start thinking that e to the power of 0 is 0 as well. Then people tend to think that 4 is equals to c. Okay, that's a very common mistake, okay, for people who like to calculate fast without using calculator. Right? That's not correct, because we need to remember that e to the power of 0 is actually 1. So it's minus 1 plus c. Okay, so do be very careful not to make such mistakes. And then the minus 1 bring over, we get 5. So c equals to 5. And therefore, the equation of the curve is y equals to x. So, x minus e to the power negative x plus 5. Exponential and your reciprocal functions. Alright? A very common kind of question when it comes to reciprocal, right, is to make use of your partial fractions. Okay, so just to do a very quick recap about what we learned about partial fraction. Okay, in fact you can refer to the little notebook I've given you. Okay, on page 2. Okay, when we have a function or a fraction like that, algebraic fraction, okay, we always check whether is it improper or proper. Okay, it is improper when the degree of the polynomial of the numerator is more than the degree of the polynomial fx. Okay, so example. Okay, for example, something like that. Right, whereby the top degree is 3, bottom degree is 2, this is more than this. Okay, proper would be maybe something like x plus 7 over x squared plus 3. Okay, something like that, whereby the top is smaller than the bottom. When the degree is the same, for example, like that, degree the same, it is still considered as improper. Okay, so because we know that as a fraction, if I have 2 over 2, right, I can still simplify it, right, so it's improper. Okay, so that's the definition of proper and improper. We learned that when it comes to improper, we need to do long division, okay, before we go about splitting it up into different partial fraction forms. Right? Okay, the forms that we have when it comes to partial fraction we observe the denominator. Okay, so if the denominator is, let's say, ax plus b, example, okay, so example, if I have x squared plus 5x over having this 3, okay, the denominator, the factors are all in linear form. Okay, we can express it okay into 3 different partial fractions. This one is a proper fraction, okay, because this one is power 2, this one adds up to be a power of 3, so the degree at the bottom is 3. Okay, then if let's say I have your ax plus b squared, for example, if I have a x plus 5 over x plus 2 times x minus 3 squared, my partial fraction will be a over x plus 2. Okay, so this factor of x minus 3 squared results in 2 separate fractions. Okay, b over x minus 3, then c over x minus 3 squared. And then, what if I have x squared plus a, or x squared plus c squared? Okay, never mind, let's do x squared plus a, okay? A being just a number, okay? So x squared plus a is something that cannot factorize, cannot factorize any further. So, example, this is dx. Okay, we have maybe x plus 5 over x plus 2 times x squared plus 3. Okay, so x squared plus 3 cannot factorize any further. So our partial fraction will be a over x plus 2 plus b x plus c over x squared plus 3. So having this results in this. Okay, trying to sum up all the things we learned in partial fractions last year. Okay. What if I have x plus 5 over x plus 2 and x squared minus 3? Slightly different. This one is plus 3, this one minus 3. Okay, what kind of partial fractions is it going to be? Right? We need to recognize that x squared minus 3 can be factorized. How we factorize it is that we recognize our a squared minus b squared. Okay, so we see it as the form x plus 5 over x plus 2, x squared minus square root 3 squared. Okay, and a squared minus b squared is actually your a plus b, a minus b. Okay, so we get x plus 5 over x plus 2, x minus root 3, x plus root 3. Okay, so upon factorization, I get 3 linear factors that is of this form. Okay, So our partial fractions would be like this. There are 3. Okay, I hope this triggers some memory. Not sure whether is it a pleasant memory or a terrible one. Okay, but it needs to trigger a memory. Okay, about partial fractions. Okay, there's a reason why we need to recap about partial fractions. Because as you can see, having fractions like that, right? It lends us very nicely to using integration of this, such that it integrates to become a ln, and then of course with the a at the bottom, So we must know how to do partial fractions. Very typically, they will always ask part A, partial fraction this, part B, integrate. So that's a standard question, Although I don't know whether it is still standard now or not. Right, let's do an example related to integration. I erase this side then. Yeah. Let's see our try 15. That this is a proper fraction. Step 1. We recognize this improper or proper first. And we notice that it is proper. Right? So once it is proper, we can proceed to the next step, which is to split it into the fractions itself. Numerators are unknown. So in this case, it means 1 over x plus 3, 2x minus 1. We see the denominator, we have one factor which is x plus 3, that will give us a over x plus 3. The other factor, 2x minus 1, will give us b over 2x minus 1. So by observing the denominator, we get a different fraction. In fact, it's called partial fraction. Then step 3, we multiply across the entire equation here by this identity, by this denominator. What I mean would be that I multiply the left hand side by x plus 3 times 2x minus 1, so it cancels out. Just writing it very small over here, so cancel out. Over here on the right is every single fraction I multiply by this same thing also. So this entire thing, multiplying by this. So for this fraction, multiplying by this, the x plus 3 cancels out. So therefore, I will get a times 2x minus 1. And then this second fraction, the 2x minus 1 cancels out. So I will get b times x plus 3. Actually I hope that you are dreaming about partial fractions. Or maybe you can dream about Miss Kong teaching you partial fraction last year. That will be great. But if you're not, then please pay attention. So multiply across by the denominator. Then after that, we look for the a and b. Hopefully you remember the method to find a and b. You can substitute suitable values. That will be easiest for this question. all compare coefficient. Okay. So I will find that substituting suitable values is here. So that means that I will let maybe x equals to -3 in order to make this 0 so that I can find out what is A. And A is -1/7. Okay, I'm doing the substitution of suitable values method here. Okay, to solve suitable values, the purpose and intention is to make one of the factors 0 in order to help us to find out what is A. Okay, then I do the same to find out what is the value of B. So in order to have 2x minus 1 equals to 0, my x is to be equals to half. If you have trouble determining whether is it half or not, okay, you can't do it mentally, just do a side calculation and you will see that the x to use is half. Okay. So left hand side remains as 1 since there's no x at all. Your A will become 0, okay, because 2x minus 1 becomes 0. So we're just looking for B. And we find B is 2/7. Okay. And then final step, reconvene, okay, back to our question, okay, to form it in partial fraction. So I'll just call it reconvene now, okay. We should answer the question, which is 1/x plus 3, 2x minus 1. It will be A is -1/7 over x plus 3 and B is 2/7 over 2x minus 1. Cannot leave an answer like that, okay? Cannot be a multi-layer fraction, cannot leave it like a kueh lapis. So, need to bring the 7 down, -1/7 x plus 3 2/7 2x minus 1. Okay? So that will be answer for the partial fraction. Okay, let you look through this a little bit. Let me know if you have any questions regarding partial fractions. Okay. If you cannot follow, this doesn't trigger any memory at all, okay, please go and find time room for me after school. Alright, I'll be more than happy to run through partial fractions with you again. Okay, just that as an entire class, I don't want to waste some people's time because I know some people may already know and can understand all this. Okay, just that if you have zero understanding, alright, please let me know. Okay, I'll see you after school. Okay. Alright, then now we look into part 2, okay, where we want to actually integrate this thing over here. Okay, we can't integrate this function without doing partial fractions because our denominator comes in 2 factors, there are 2 parts to it. Okay, this does not look anything like our integration rules over here. Because in our integration rules, the denominator is only one single factor, ax plus b. Okay, it doesn't come in 2 separate parts. And we don't have anything about product rule, quotient rule, none of that. Okay, that is the reason why, in order for us to integrate things like this, we must go through the entire partial fraction process in order to arrive at this. Because once we arrive at this, I recognize that maybe this is easier to recognize, that I have my denominator as x plus 3, which fits this bill over here, and the denominator is 2x minus 1, which fits this over here. Okay? So therefore, doing partial fraction is necessary when it comes to integration of such a thing. Okay? So let's go into solving part 2. Where the question says, hence find integration of this. Okay, so to integrate this thing using our part I's answer, we see it as integration of negative 1 over 7 x plus 3 plus 2 over 7 2x minus 1. Okay? Sometimes because of this 7 in the denominator, it may confuse you a little. So I want to help all of us see that integrating these two fractions here is the same as thinking it as though we take out the negative 1 over 7, okay, and multiplying it with 1 over x plus 3. Okay, so I want you to see that this and these fractions are equivalent to each other. Likewise, for the other fraction, it is the same as 2 over 7 multiplied with 1 over 2x minus 1. Okay, then we can bring out this negative 1 over 7, integrate this first part, followed by taking out the 2 over 7 and integrate 2x minus 1, 1 over 2x minus 1. Will be negative 1 over 7. Okay, integrating 1 over x plus 3 gives us ln x plus 3. Okay, coefficient of x is 1, so actually it's divided by 1. Then plus 2 over 7 ln 2x minus 1 divided by 2. Okay, and then we put the plus c at the end. Okay, I really don't bother with putting plus c here and plus c here, or plus c and plus c. Okay, just put all the constants together and represent with one constant. Good enough already. Okay, don't need to be too picky about showing so many constants. Okay, then we proceed in simplifying. So these two can cancel out. Okay. If the question did not demand for more, you can leave your answer in this final answer here. Okay. I just want to push us a little because sometimes the question may demand for more in terms of a certain logarithmic form. Okay, so you can see this one is minus, right? Let me just swap this around first. I put the positive one in front. Okay, since there's a factor of 1 over 7 for both, let me just factorize that out. Okay, we see that this is a difference of two logarithms. Can apply your logarithmic law, and that will be to take 2x minus 1 divided by x plus 3. Okay? So you can apply your logarithm's law, okay, and arrive at this more compact answer, right, which may sometimes be an expectation, okay, in the exam question. Because sometimes they may say, hence find this in a particular form. Okay? So this might be something you need to learn how to arrive at as well. Okay? Questions? Okay. No question. I think enough of me talking, so let's let you do one. Okay, let's do exercise 16.3, question 8b. Okay, find the integral of 1 over x squared minus 1 times x plus 1. Okay, this one will require partial fraction first. Okay, make sure you recognize your factors properly, form your partial fractions correctly. Okay, give you about 10 minutes to work on this. If you're unsure how to even start, please let me know. I'll come to you. Okay. On the whiteboard, I leave some checkpoint answers that you should arrive at. Okay, for the partial fraction form and the final answer. So we have x plus 1, x minus 1, x got 2x plus 1. And this 2x plus 1 simplified becomes a x plus 1 square, right? Okay, and then fit the bill so you see x plus 1 square and so if you skip that step, you don't realize that you needed this step because of the factor x plus 1. After I do the thing, then I see that it needs single values. So you can have this at that skip this step one. You show me x squared minus 1 is going to give us x plus 1, x minus 1, and then simplify x plus 1 by the square times x minus 1 so that you can understand why we choose this. Yes, correct. Correct. But then, so you get square minus 1 again, because of that. Okay. Square root 1 is what? So, so just put 1 lah. Usually put square root 1 and simplify it. Okay. So you can see then have x plus 1, x plus 1. You x plus 1 square, right? So actually shouldn't be having 2 separate. Yeah, because x plus 1 bracket square will give you what? Kind of form. Yeah, correct. Can I integrate it? What do you mean? Okay, so you see, whenever they ask you to integrate, integrating 3 1 over x cubed minus non-x squared x cubed will give us non-x cubed over x squared plus c, right? Agreed? Okay, so let's break this up. Okay, I can bring out the 3 first and then I can divide the 3. Right? So skip a little bit of steps. Okay. This integration is taking this 3 out and dividing over, so I get non-x cubed over x squared. They divide by 3, so I got 3 later, plus c, I divide by 3, that is c. Okay? Then this thing, the focus was here. Okay, I want to bring this out, make this a subject. So I have this thing in the mini. Okay, let's break this integral up into 2 parts. Okay, integrating this. Yes, so that we are making this a subject, which is what I want to find by and whatever is here. Then I can integrate this. Continue, or I write the answer on the whiteboard. we are still doing. Okay, generally when I walked around, I think most of you are able to capture the essence that you're supposed to factorize your x squared minus 1, such that gives you x minus 1, x plus 1. Okay, but do be very careful, we cannot recognize this as three distinct factors because x plus 1 and x plus 1 can be simplified to give us x plus 1 squared. Okay, because that will change how we express our forms for the partial fraction. Your x minus 1 will give us a over x minus 1. Your x plus 1 square will give us two separate partial fractions, one with x plus 1 as denominator, the other one x plus 1 square. Okay, I do not encourage that you try to skip steps over here and try to do a mental calculation because you will have the tendency to make careless mistakes that way. Okay, then we multiply across by this factorized denominator already, okay, such that we have 1 on the left hand side and then the right side individually we are multiplying by this denominator, okay, and by cancellation we will have all these things, okay, over here written as a line. Right? Then we do by substitution of suitable values. We want to create zeros, okay, in these factors so that it helps us to find out our A, B, and C easily. So to find out A easily, I see that the other two has x minus 1. I try to make x minus 1 0. Okay? So that's why I have zeros over here and A is 1/4. I do the same again in order for us to find out what is C because the other two has x plus 1 as factors and for x plus 1 to be 0, x should be negative 1. Okay, so I find out what is C. Right? But then in order to find B, we notice there's no common factor between these two parts. So you can decide and choose any number that you like. You want to choose 1 million also can. Just that it will be difficult in calculation. I like simple numbers, okay, and 0 is simple enough because once I have 0, then we're just looking at 1 square, okay, 1, negative 1, easy for us to calculate. Okay, so that explains why I have 1 square over here. A has been substituted by 1/4, and then my C has been substituted by negative half. Then I can find my B value. Then I reconvene to get this partial fraction form. Okay, then we do our integration. Right? Take note that for this integration, because denominator is a square, okay, we will be using our power rule. So it is actually integrating something to the power of negative 2. Right? And that will mean that I need to add power plus 1 divided by the power. Okay? And then this will be my final answer. Alright? I'll just leave this here. Okay? Go back, think about it, especially if you're half done. Please make sure that you understand. Okay, if you still have any questions, please let me know. Tomorrow, I'm going to return to you your EMATS WA2. Okay, so if I finish your EMATS WA2 already, then I will run through integration again. Okay, or rather, I will continue with integration.
没错，我觉得。